Assalamu Alaikum. Hello my dear students. So in the previous class we have discussed about the characteristics of P block elements. So in this class we are going to discuss about how to find the group number of D block elements. Okay. So in your text in page number 23 there is a table. You can see that and how to find the group number of D block elements. Okay. So we know that the electronic configuration of scandium is what is the atomic number of scandium? It is 21. Okay. So we can write the electronic configuration of scandium. How we can write the electronic configuration of scandium? So in the outermost shell there is 3D1. I didn't write the electronic configuration full. I only write the electronic configuration from D block and at the end electronic configuration മാത്രമാണ് ഞാൻ എഴുതുന്നത്. Okay. So the scandium the electronic configuration is 3D1 4s2. ഇതാണ് last subshell. This is the last two subshells. So for the D block element we add the number of electrons in the S subshell and D subshell. Then what is the group number of scandium? It is 1 plus 2. It is equal to 3. Okay, this is the electronic configuration of scandium because it is in the D block element. When we calculating the group number of D block elements, we add the number of electrons in the S subshell and D subshell. Okay. Then there is another example, titanium. Okay, titanium. The atomic number is 23. Titanium atomic number is 22. Okay. In the outermost, the last subshell, അതായത് D subshell and 4 subshell, last configuration മാത്രമാണ് ഞാൻ എഴുതുന്നത്. You know how to write the full electronic configuration. So just I write only the last electronic configuration of the element. Scandiumത്തിന്റെ last subshell 3D1 4s2 എന്നാണ് വരുന്നത്. Okay. And titanium, the atomic number is 22. How to write the electronic configuration? The last electronic configuration that is 3D2 4s2. Okay. 3D2 4s2. So the group number, when we finding the group number of D block elements, we add the S subshell, the number of electrons in the S subshell and number of electrons present in the D subshell. So we get 4. Okay, the group number of this titanium is 4. So hence in this way we can find out the group number of D block elements. So what is the speciality of D block elements from the other elements, from the other group? അതായത് the group number of D block elements will be the same as the sum of electrons in the outermost F subshell and the number of electrons in the preceding D subshell. അതായത് നമ്മൾ എന്ത് ചെയ്യുന്നു, when we calculating or when we find the group number of D block elements, we add the number of electrons in the S subshell and also we add also with that we add the number of electrons in the penultimate shell, that is the D subshell. We add both of, okay, നമ്മൾ രണ്ട് ആഡ് ചെയ്യും. അതായത് ഗ്രൂപ്പ് ബാക്കിയുള്ളതിൻ്റെ എല്ലാം in the remaining അല്ലെങ്കിൽ in S block elements and P block elements there is we only consider the last subshell. Here in D block elements we consider the S subshell, number of electrons present in the S subshell and number of electrons present in the D subshell. In this way we can calculate the calculate the group number of D block elements. Okay, so the group number of D block elements will be the same as the number of electrons present in the S subshell plus number of electrons present in the D subshell. The D subshell is the penultimate, മുമ്പുള്ള എസിന് മുമ്പുള്ള പെനൾട്ടിമേറ്റിൻ്റെ ഷെല്ലിൻ്റെയും ഇലക്ട്രോണിക് കോൺഫിഗറേഷൻ നമ്മൾ number of electrons നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യുന്നു. So in this way we can calculate the group number of D block elements. So this is about how to calculate the group number of D block elements. Then we are going to discuss about the characteristics of D block elements. Okay. So when we calculating the group number of D block elements, we add number of electrons present in the S subshell and we also add with this we add the number of electrons present in the D subshell also. Okay. So next we are going to discuss about the characteristics of D block elements. Okay. Characteristics of D block elements. Characteristic D block. Okay, so in the previous classes we were discussed about the characteristics of S block and P block. In this class we will discuss about the characteristics of D block elements. We know that 3 to 12 up to from 3 to 12 we can see the D block. From 3 to 12 D block are otherwise called transition elements. Okay, D block are otherwise called transition elements. Okay, 3 to 12 ആണ് എന്ന് പറയുന്നത് between S and P block. Okay, between S and P block we can see the D block elements between 3 to 12 and it is between the S block and P block. S block-നും P block-നും ഇടയ്ക്കായിട്ടാണ് ഏത് വരുന്നത്? The D block. Okay, then the second point is they start from the third period. Fourth period, sorry, third period alla, fourth period. Okay, they start from the fourth period. The second point is they start from the fourth period. And what is the another characteristics of D block element? The last electron filled in the D block. Okay, അതായത് ലാസ്റ്റ് ഇലക്ട്രോൺ എവിടെയാണ് ഫില്ല് ചെയ്യുന്നത്? The last electron filled in the എവിടെയാണ്? D block. Okay, the last electron filled in the D block. Then എന്താണ് ഇതിനെ വേറൊരു പേരിൽ നമ്മൾ അറിയപ്പെടുന്നു? The D block elements is otherwise called what? Transition elements. The P block elements otherwise called transition elements. So the P block elements start from 3 to 12 between S block and P block and it is come in the period fourth period and the D block are otherwise called transition elements. Then how we calculate the how we find the group number? How we find the group number? We add outermost electron in the D subshell plus outermost electron in the S subshell. So in this way we can find the group number. Okay, group number of D block elements. So what are the characteristics? It comes under 3 to 12 between S block and P block. It is in the fourth period and it is also called transition elements. And when we how we calculate the group number of D block elements? Number of electron present in the S subshell and plus number of electron present in the D subshell. D subshell is the penultimate shell. Okay, in this way we calculate the group number of D block element. Then there is a special character for the D block elements. We can check the special character of D block elements. Okay, so special character. There is a special character for the D block element. Now we can check the what is the speciality of this D block elements. So oxidation state of D block elements. എന്താണ് oxidation state of D block elements? Oxidation state of D block. Okay, so this D block show different oxidation state compared to other groups. Compared to S block and P block, the D block show different oxidation status. Okay, so we know that the iron is present in the D block and iron has two compounds. Which are they? Iron has two compounds, ferrous chloride and ferric chloride. Okay, ferrous chloride and ferric chloride, FeCl2 and FeCl3. This is the ferrous chloride and this is the ferric chloride. Ferrous chloride, there is two compounds. Iron formed two compounds. Which are they? Ferrous chloride and ferric chloride. Okay, ferrous chloride, ferric chloride. So the iron form two chlorides or two compounds, iron, ferrous chloride and ferric chloride. Okay, so in D block elements there are two oxidation states shown by the iron, Fe2 plus and Fe3 plus. These are the two oxidation states shown by the iron. Iron is in the D blocks, hence it show different oxidation state. It is the speciality of the D block element. Okay, so in normal the iron show different oxidation state. Which are they? Fe2 plus and Fe3 plus. And iron, we can write the electronic configuration, normal electronic configuration of iron. First of all we can write the electronic configuration of iron. So we can write 1s2. What is the atomic number? What is the atomic number? എത്രയാണ് അയണിൻ്റെ അറ്റോമിക് നമ്പർ എന്ന് പറയുന്നത്? ഓക്കെ, അതായത് 26. The atomic number of iron is 26. And how we can write the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6. Then what? 3d6 and 4s2. Okay. First of all, we fill the s subshell and then we fill the d subshell according to our rule. But when we write the electronic configuration fully, we first write the d block and then filling of electrons first in the s subshell. Okay. So this is the full electronic configuration of iron. This is the normal electronic configuration. Okay. When we can in the case of noble gases, we can write argon 3d6 4s2. Argon 3d6 4s2. This is the electronic configuration of using noble gases. Argon is the noble gases. We already learned about the electronic configuration, how to write the subshell electronic configuration using noble gas. So this is the way of how to write the electronic configuration using the noble gas. Okay. So this is the normal electronic configuration of iron and when we write the electronic oxidation state, when we write the different oxidation state of iron, first of all Fe2 plus. How we can write Fe2 plus? Fe2 plus എഴുതുമ്പോൾ എങ്ങനെ വരും? 1s2 2s2 2p6 3s2 then 3s2 then 3p6 and 3d6, because we know that 2 plus 2 electron losses here from iron. Here 2 plus, we can see the oxidation state 2 plus. Then what we can understand from this, iron loses 2 electron, hence the electronic configuration is here the normal electronic configuration of iron. What is the electronic configuration? 3d6 4s2. But when we write the oxidation state, that is Fe2 plus, it loses 2 electrons and what is the electronic configuration? 2 electron losses. Okay, 2 electron loss ചെയ്യുന്നു. Then what is the electronic configuration? 1s2 2s2 2p6 3s2 3p6 3d6. There is the absence of 4s2. What is the reason behind it? എന്താണ് അതിന് കാരണം എന്ന് പറയുന്നത്? ഇവിടുന്ന് 2 ഇലക്ട്രോൺസിനെ ലോസ് ചെയ്യുന്നു. Okay, the iron loses 2 electrons, Fe2 plus. Then how we can write the electronic configuration of Fe3 plus? Here ഇവിടെ 2 ഇലക്ട്രോൺസ് ലോസ് ചെയ്യുന്നു. Fe3 plus വരുമ്പം എത്ര ഇലക്ട്രോൺസ്? How many electron losses? 3 electron losses. Then we can write the electronic configuration 1s2 2s2 2p6 3s2 3p6 and 3d5. Okay, അതായത് 3 ഇലക്ട്രോൺസ് ലോസ് ചെയ്യുന്നു. Then 3 electrons lose ചെയ്യുന്നു. Then how we can write the electronic configuration? 1s2 2s2 2p6 3s2 3p6 3d5. അതായത് 3d6ൽ നിന്നുള്ള 1 ഇലക്ട്രോണും 4s2 നിന്ന് 2 ഇലക്ട്രോൺ, അങ്ങനെ 3 electrons lose ചെയ്തു. Then the remaining electronic configuration is this. Okay, what is the speciality of this d block element? The speciality of the d block element, it shows different oxidation state. Okay, it shows the different oxidation state. Okay, there is only small difference between the energy. അതായത് ഈ എന്തുകൊണ്ടാണ് why the d block elements show different oxidation state? Why the d block element shows different? We were നമുക്കറിയാം, we know that the p block and s block does not show different oxidation state. Only the d block show the different oxidation state. What is the reason behind it? എന്താണ് അതിന്റെ കാരണം എന്ന് പറയുന്നത്? The reason is that the energy between the S and D is very small. അതായത് ഇവ തമ്മിലുള്ള എനർജി ഡിഫറൻസ് എന്ന് പറയുന്നത് വെരി സ്മോൾ ആണ്. അതായത് എസ് സബ്ഷെല്ലും ഡി സബ്ഷെല്ലും തമ്മിലുള്ള എനർജി ഡിഫറൻസ് ഈസ് വെരി ലോ, ഹെൻസ് ഇസ് സോ ഡിഫറെൻറ്റ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ്. that is the reason why the D block elements show different oxidation state, because there is a small energy difference between S and D block, so it is show different oxidation state, which show the D block elements show different oxidation status. Okay, so in your text in table 1.17 you can see the compounds of manganese. You just write the compounds of manganese and oxidation. You also check the oxidation state of manganese. Okay, manganese in the oxidation state, different oxidation state എഴുതിയിട്ട് അതിൻ്റെ electronic, you just find out the electronic configuration of subshell electronic configuration of manganese. Okay, നമ്മൾ ഇത് ഇവിടെ ചെയ്തതുപോലെ തന്നെ, there is no difference in that. Okay, so so in this class we were discussed about characteristics of D block elements and how to find the D block elements. Okay, so hope you have understand that the two concepts. Okay, how to find the electronic configuration of D block elements? We add the number of electrons present in the s subshell and number of electrons present in the d subshell. In this way, we can calculate the group number of D block elements, and we also discussed about the characteristics of D block elements and the different oxidation state shown by the D block elements. What is the reason behind this different oxidation state? Because the energy difference between the S block and S ബ്ലോക്കും D ബ്ലോക്കും തമ്മിലുള്ള എനർജി ഡിഫറൻസ് എന്ന് പറയുമ്പോൾ ഇറ്റ്സ് വെരി സ്മാൾ, സോ it show different oxidation state. Okay, so in the next class there is one portion remaining for the next class, that is the characteristics of F block elements. Okay, adambodathekku chapter will end. Okay, in the next class there is only a small portion remain for this end of the chapter, so now we can wind up the class. Thank you.